Good morning, my dear students. Today we shall learn theorems of complex numbers from 4 to 6. Theorem number 4, prove that for all Z1, Z2 belongs to complex number C. Then Z1 plus Z2 conjugate equal Z1 conjugate plus Z2 conjugate. So likewise, Z1 is equal to x1 plus iota y1. Suppose this is a question number 1. In the same way, z2 equal x2 plus iota y2. A question number 2. Now what we have to do, you can see left hand side z1 plus z2 conjugate. It means first of all, we have to find z1 plus z2. For this, adding equation number 1 and 2. Z1 plus Z2 equal x1 plus iota y1 plus x2 plus iota y2. So boys, separate real, collect real and imaginary parts. X1 plus x2, this is real part, plus taking iota common, y1 plus y2. Now you can see z1 plus z2 is equal to real part plus iota imaginary part. Taking its conjugate on both sides, z1 plus z2 conjugate equal x1 plus x2 plus iota becomes minus iota y1 plus y2. Now open the bracket, x1 plus x2 minus iota y1 plus into minus minus iota y2. Write in its original shape x1 minus iota y1 plus x2 minus iota y2. This is z1 plus z2 conjugate. So guys, you can see z1 plus z2 equal, this is conjugate of z1 plus this is conjugate of z2. In this way, you can prove this theorem. Yes guys, theorem number 5. For all, this notation represents for all. For all z1, z2 belongs to complex number, then prove that z1 dividing it by z2 whole conjugate equal z1 conjugate dividing it by z2 conjugate, where z2 is not equal to 0. Likewise, z1 equal x1 plus iota y1. Equation number 1. Similarly, z2 equal x2 plus iota y2. Equation number 2. What we have to do? We have to divide z1 by z2. So, dividing equation 1 by equation 2. z1 dividing it by z2 equal x1 plus iota y1 dividing it by x2 plus iota y2. By rationalization, z1 dividing it by z2 equal x1 plus iota y1 dividing it by x2 plus iota y2 multiply x2 minus iota y2 dividing it by x2 minus iota y2. So boys, right here x1 plus iota y1 multiply x2 minus iota y2. Dividing it by, you can see a plus b into a minus b. We have the formula a square minus b square. So take x2 whole square minus iota y2 whole square. So multiply x1 by x2, it becomes x1 x2. x1 by minus iota y2 minus iota x1 y2 plus iota y1 by x2. It becomes plus iota y1 x2 minus plus minus iota multiply iota square y1 y2 dividing it by x2 whole square minus iota square minus 1 y2 square x1 x2 minus iota x1 y2 plus iota y1 x2 minus iota square minus 1 y1 y2 dividing it by x2 square plus y2 square z1 over z2 equal x1 x2 minus iota x1 y2 plus iota y1 x2 minus into minus plus y1 y2 dividing it by x2 whole square x2 square plus y2 square. Now boys, we have to collect these real x1 x2 plus y1 y2 plus iota common y1 x2 y1 x2 minus x1 y2 dividing it by x2 square plus y2 square. This is z1 dividing it by z2. Taking conjugate z1 dividing it by z2 conjugate x1 x2 plus y1 y2 dividing it by x2 square plus y2 square. Iota becomes minus iota y1 x2 minus x1 y2 dividing it by x2 square plus y2 square like this. Now boys, you have to open the brackets x1 x2 plus y1 y2 minus iota y1 x2 plus iota x1 y2 dividing it by x2 square plus y2 square. So write z1 over z2 whole conjugate. Now boys, write x1 x2 minus iota y1 y2. In the same way, y1 y2 plus iota x1 y2 x1 x2 minus iota y1 x2 plus iota x1 y2 plus y1 y2 dividing it by x square x2 square plus y2 square. z1 dividing it by z2 whole conjugate. Now by taking x2 common, x1 minus iota y1 plus iota y2 plus iota y, just a minute, this is y2. Taking y2 common, iota y2 common, x1 minus iota y1 dividing it by x2 square plus y2 square, z1 dividing it by z2 whole conjugate, z1 dividing it by z2 whole conjugate equals x1 minus iota y1 x2 plus iota y2 dividing it by x2 square plus y2 square, x1 minus iota y1 x2 plus iota y2 dividing it by, now factors of x2 square plus y2 square, the factors will be x2 plus iota y2 into x2 minus iota y2. Now you can see x2 plus iota y2 is cancelled by x2 plus iota y2. So it becomes x1 minus iota y1 dividing it by x2 minus iota y2. So z1 dividing it by z2 whole conjugate will be equal to, this is actually the conjugate of z1 and this is actually the conjugate of z2. In this way, while we can prove this theorem, very important. So you have to learn many times. You have to study so many times. Theorem number 6. For all z1, z2 belongs to complex number C, then prove that z1 multiplies z2 conjugate. Theorem number 6. For all z1, z2 belong to complex number C, then prove that z1 multiplies z2 modulus equal z1 modulus multiply z2 modulus. Let z1 equal x1 plus iota y1. Equation number 1. z2 equal x2 plus iota y2. Equation number 2. Guys, what we have to do? You can see in your left hand side, z1 and z2 actually they are multiplying. So multiplying equation 1 and 2, z1 multiply z2 equal x1 plus iota y1 multiply x2 plus iota y2. Now multiply x1 by x2, it becomes x1 x2 plus x1 by iota y2, it becomes iota x1 y2 plus iota y1 by x2, it becomes iota x2 y1 plus iota y1 multiplied by iota y2, iota square y1 y2. So this is z1 multiply z2. z1 multiply z2 equal x1 x2 plus iota x1 y2 plus iota x2 y1 iota square, it becomes minus 1, so minus y1 y2 z1 multiply z2 equal real parts x1 x2 minus y1 y2 plus iota common x1 y2 plus x2 y1 taking modulus z1 multiply z2 modulus equal square root. Modulus mean we are taking square root x1 x2 minus y1 y2 plus iota x1 y2 plus x2 y1. Real part square plus iota imaginary part taking modulus z1 multiply z2 equal modulus mean we have to take real part x1 x2 minus y1 y2 whole square plus square of imaginary part x1 y2 plus x2 y1 whole square z1 multiply z2 modulus equal square root x1 x2 whole square plus y1 y2 whole square minus 2 x1 x2 y1 y2 a plus b minus b whole square, here a plus b whole square, so it becomes x1 y2 whole square plus x2 y1 whole square minus 2 plus 2 x1 x2 y1 y2. So minus 2 x1 x2 y1 y2 is cancelled by plus 2 x1 x2 y1 y2 is equal to square root x1 square x2 square plus y1 square y2 square plus x1 square y2 square plus x2 square y1 square. This is absolute or modulus value of z1 and z2. z1 multiply z2 modulus equal square root x1 square x2 square plus x1 square y1 square plus y1 square y2 square plus x2 square y1 square equal square root x1 square x2 square plus x1 square y1 square plus x2 square y1 square plus y1 square, just rewrite y2 square square root taking x1 square common x2 square plus z1 multiply z2 modulus equal square root x1 square x2 square plus x1 square y2 square plus x2 square y1 square plus y1 square y2 square. Square root taking x1 square common, x2 square plus y2 square plus y1 square common, x2 square plus y2 square equal square root x1 square plus y1 square and x2 square plus y2 square. So we can write square root multiply square root x1 square plus y1 square into square root x2 square plus y2 square. This is the value of z1 modulus. Multiply, this is the value of z2 modulus. In this way, boys, you can solve this theorem. So, inshallah, tomorrow we will start the new topic. Thank you very much. Allah Hafiz.